Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. Now, we haven't spent much time talking about the scope of variables up to this point. We did see how scope would impact the lifetime of an object in the previous lesson, talking about as object references go out of scope, so as the current execution flow for the application extends beyond the end of the sub, what happens to our objects in memory? Well, they get garbage collected, right? But I want to take some time and talk about scope, and I want to make sure that you understand local scope and scope at a module and class level, and so that you can more completely understand the topic, and then we'll use that as a launching board to get into visibility. And so there are visibility modifiers like the public keyword, and there's also a private keyword. There's several others in relation to writing classes, and then methods and properties inside of those classes, and how those keywords, those accessibility modifiers, change the visibility of classes and their members. All right, so before we jump into accessibility modifiers, like I said, I want to talk about variable scope. So let me start by saying that whenever you declare a variable inside of a block of code, that variable is really only alive and accessible for the life of that block of code. Meaning that whenever that block of code has finished executing, the variable defined inside of that block of code is no longer accessible. Its values are disposed of by the .NET Framework runtime. So I want to see how that applies to common code blocks that we've been working with up to this point, and kind of extend out from there. And to begin, what I want to do is go to the before folder for this lesson. And so wherever you currently are watching this video, or where you originally downloaded it from, there should be a folder of code. We're going to look at the before folder to grab out our understanding scope project. And I'm going to copy it. Personally, I'm going to copy it into my projects directory here so that I can find it with all my other projects. I'm going to double click the solution file inside of that project folder. And you'll see that we have just a simple car class, and then also our module 1.vb with an empty submain. And so what I want to do is create a small project to understand scope a little bit better. And I want to test how variables that are defined inside of a code block work as we move outside of those code blocks. And so it's going to be a very simple example at first, and we'll just keep building on it. But any variable, whether it's a simple type, like strings and integers, or something more complex or custom like the car class, it still applies what we'll talk about here in this lesson with regards to scope. And I just wanted to make you aware of that as we get started. So to begin with, inside of here, let's start with a console.readline. And then above that, I'm just going to create a for statement. So for index equals 1 to 10. In fact, I'm going to change this from index just to the letter I to stay consistent with the rest of my code I'm planning on writing. And while we're inside of this code block, the I that is declared here and initialized to the value of 1 and will be incremented as we go through the for loop, we can access its value inside. And we can see that quite obviously. We can print out 1 through 10. But what happens if I try to access that outside of the code block in which that I was defined? Well, in that case, we'll try to go here and print it out and run our application. First of all, we get a compilation error. We get a little red squiggly. I is not declared. It might be inaccessible due to its protection level. Its protection level has nothing to do with it, or its accessibility level. The fact of the matter is that I is out of scope because it was declared inside of this code block. It's not available outside of that code block. All right, so that's the lesson here that we want to take away. So we're going to look at some other common usages and show what you would have to do to make this work. So let's go outside of this and do dim j as string equal to an empty string. And then inside of our code block, I'll just go j equals I dot toString, like so. And then can we actually view it here? And so actually let me do this just to make sure we know what we're dealing with here. So j equals, and then let's do I is, all right, so that should be pretty clear. Let's go ahead and run the application. Now you can see that, first of all, I is 1 through 10, and then because j was declared outside of our code block, our for next loop, we're able to access its value, its current value, which was set to the last value that I was set to, which was 10, and it's printed out here outside of our code block, right? Okay. So now let's take this one step further, and what I want to do is define a variable outside of submain. We've never done this before. When I create it like this, it's called a field, a private field. So it's a variable that's accessible then to all of the methods that are inside this module, all right? So we'll use the private keyword, and I'll come back to that a little bit later. Private k as string, and I'll even initialize it to just an empty string, all right? So here what we'll do, inside of the loop is exactly what we did here, I.toString. And I am pretty sure that we're going to be able to access it here as well, but we'll just make sure by doing that. Now outside of this, we'll call, or we'll create a private sub helper method, like so. And then inside of this, what I'm going to do is console.writeLine, and we're going to go k, but we're going to do it from our helper method. Like that. And then we'll print out the value of k. And then finally what we'll do is we're going to need to call that helper method here. So again, I can just call helper method by giving it its name and using the method invocation operator. And now let's see if we're able to access the value of k inside of this method, even though we created it outside of all of the methods and set its value inside of our submain. Let's run the application. All right, and you can see the results here when we get near the bottom, k is equal to 10, and then when we call the helper method, its value is 10. So we're able to access, or the scope of the variable defined here outside of, or as a, you could think of this as a relationship, as a sibling relationship to submain and private sub helper method. It's accessible then to its siblings at the same level, all right? So let's continue on. Now let's go inside of this for loop, and we'll go and create an if I equals 10, then we're going to dim L as string equals I.toString, and I'm going to do console.writeLine L, and then we'll print the value of L right there, okay? I think you should probably be able to figure this one out without me telling you, but I'm going to go ahead and try this anyway. What do you think will happen here? Well, you can already see we get a red squiggly line. L is not declared. We're trying to access it outside of its code block. Now, what if we were to do this? We know we can't access it there. Can we access it in this code block? Well, no, we still can't because it's outside of the code block in which it was declared, so it's no longer accessible. So unfortunately, those will not work. All right. So hopefully, if you've had any confusion or misconceptions around variable scope, this little exercise that we just went through will help clear some of that up. And now what I want to do is to move on to a more important topic of accessibility modifiers. Why do we use public and private, for example? So in the methods that we've written in the previous lessons, we always started with the word public. In this case, I started with the word private here for this little variable and for this method. And public and private are called accessibility modifiers. They're used to implement a tenet of object-oriented programming called encapsulation. So in a nutshell, classes should be little black boxes, like black boxes on an airliner, which record every move that the airline or that the airplane makes, and so if it does crash, then they can find out. But the black box will has no other controls on it. It'll just automatically record everything. And so I think maybe even a better example might be those old style television sets. You may have had one in your home. I'm a little bit older, so I remember the days when my parents or even my grandparents, you'd have to get up from your seat and actually push a button or turn a knob in order to turn the television on or off, or to turn the volume up or down, or to change the channel, okay? There were no remote controls. The kids were the remote controls back in those days. So you had only just a couple of knobs and dials and buttons. And there was maybe also a place on the back to attach an antenna, and then maybe a plug, and you plugged in the television set into the wall. But everything else was enclosed, encapsulated inside of this magic box, okay? It's all self-contained. And as a kid, I would be fascinated whenever my dad popped off the back of the television set to replace a tube to fix one of the tubes. Yeah, you used to be able to do that sort of thing. It still seems like magic to me that, first of all, my dad could even figure that out. And then secondly, you know, all the complexity inside of the box once we opened up the back and took a look at it. Now, all I know as a kid, and even to this day, all I know is the public interface, the buttons, the knobs, you know, the electricity. I can plug it in, I can hook up the antenna, but that's about it when it comes to television sets. And frankly, you know, that's all you really need to know about a television set to use it, right? As the consumer of the television, I just need to know the simple controls, and everything else is encased inside of plastic, and it's all hidden from the end user. And that's the way that it should be when you create your classes. Classes should be like little TV sets that are all the complexity of it is closed off. You just have a couple of public interfaces that consumers of the class can utilize, but everything else is hidden in private, so that somebody can't get in and just start making changes to it and potentially break the class. All right. So the behind the scenes functionality, especially for methods, should be encapsulated behind interfaces like public methods and public properties. Now, classes may have private properties, or rather private fields, like something like we created right here, as well as private methods like the one that we created here in this module, and to use as like helper methods, and they're used to enable all the magic that goes on inside of our class. But the consumer of the class doesn't know anything about these private members, these private properties, and the private methods. It has, and it shouldn't have, any knowledge of the underpinnings of the actual class itself. All that the consuming class needs to know about is what's publicly exposed through public properties and methods. All right. So in a nutshell, private means that the method or the property, but specifically the method, can be called by any other method inside of the same class definition, but it can't be called outside of the class definition. So that's why I use the term private helper method, because typically a helper method, that term helper method, is used to provide some additional functionality that outside of a given class, it should not be able to see it, but inside the class, it just provides some additional features that can be utilized by the public methods. All right. So at any rate, a public method will then be accessible to outsiders. That's what they'll call to get their work done. Private methods are going to be used by insiders, those who are those methods that are also declared inside of the same class. So here what we'll do in our car class is actually create a private helper method. In fact, I'm going to call this private function helper method as string, and I'm just going to do something really simple. Howdy, partner. All right, so all it does is just return a string, nothing fancy at all. But let's pretend for a moment that that's all the business logic and complexity of our application, and it's all hidden there inside of a private method. Now, I may create a public method. So public sub do something important, like so. And here I might just do console.writeLine, and then I'll call the helper method, okay? So just a real quick caution, you probably don't want to ever put a console.writeLine inside of a class. There's a long reason why we have two concerns now that are munged together in the same code. I don't want to go into depth, but typically you would just want to return back a string and then let module 1 actually print that to screen. But at any rate, just felt like I needed to give you a little bit of a caveat there. So let's go here after we've done all of this work. In fact, let me select it all and I'm going to comment it all out. And here what we'll do is go dim my car as new car, and then my car dot, and notice that I can see the do something important, but I can't see that little helper method, okay? Because it's private, it's hidden from me. So all I can know to do as the consumer of the car class is to call do something important. Behind the scenes, I don't know what's going on. Now, you know, that's a little bit of a misnomer. I, as a programmer, can look here and see, oh, I see what it's doing. But we're talking about this from the perspective of the code that's doing the calling. It cannot see into the implementation of that class. It shouldn't have any knowledge of what's going on and how it's actually doing its implementation. So yes, in a sense, because we're the programmer, we can see what's going on inside, but we don't want any other objects to go in there and fiddle around and make any changes or be able to call the helper method independent of the higher level public do something important method. All right, so you have to kind of use your imagination and work anthropomorphically in the code, looking at it from the perspective of the sub main, not from the eyes of the software developer. All right, so here, let's run the application now. You probably guessed what you'll see. Just the words howdy partner. Actually, the example is much less impressive than the concept itself. Admittedly, this is extremely mundane. It's a simple example that's only real value is to illustrate the notion of encapsulation. So we're hiding the implementation, but exposing a public interface that's available to consuming code like submain. All right. So the purpose of this lesson is to better understand the notion of scope, because we said once variables, especially those variables that are holding on to references to objects in our computer's memory, after they go out of scope, then those variables values are no longer accessible. The .NET runtime gets rid of them. Garbage collection then will remove any of the objects in memory that no longer have any references to them. Furthermore, it's important to understand that there are parts of classes that you have access to, and then there are parts of classes that you won't have access to. So there are probably many more methods in the .NET Framework class library that you don't have access to because they're hidden behind the private accessibility modifier, all right? Now, if you ever do decide at some point in the future to build your own custom classes, then you should strive to expose public methods and give a simple, straightforward, obvious usage for your class while keeping other helper methods that implement the logic of your class privately tucked away and not available to the prying eyes of the consuming code. All right. You want to give the code that's calling into your class a way to use the class properly through the methods that you designed and the input parameters and the return values. So this removes ambiguity whenever you're very clear about the way to call into a class. It makes its usage much more clearer and obvious as well. And so in the .NET Framework class library, methods and properties are exposed using the keyword public. They may also use private methods, but we would never know about that, right? So they might use other types of accessibility as well. We only talked about public and private. There's one called protected. There's another one called, I believe, internal, and some others. But they're used primarily whenever you're building a much richer inheritance relationship between classes, when you're building this rich class hierarchy, a library of functionality, and most of us probably won't need to do that, not for some time. So you really don't need to know those just yet. But again, they're available. It's just kind of beyond the scope of what we want to talk about here, absolute beginner topics. But some of those topics I cover on DevU, especially for C# developers. So just to recap, in this lesson we talked about variable scope, how variables have a lifetime based on the code block in which they're defined. When the current code block is part of the current scope of the execution at runtime, the variable will be available, but once you exit out of that code block and the flow of execution extends beyond the definition of the code block, then those variables will no longer be available. We also talked about accessibility modifiers like public and private and how that impacts the way that the .NET Framework class library is accessed, that we can only get to the public methods. And even perhaps someday when we build our own class libraries for our own applications, we might want to use accessibility modifiers to control what the consumers of our classes actually can see. And we want to hide any helper methods behind the private keyword while exposing methods using the public keyword. All right, so we're doing great. Hang in there. We're getting close to the end, believe it or not. A lot of the complexity we've already covered. You're doing great. We'll see you in the next lesson. Thanks.